Dear students, welcome to today lectures on Unit 1 PDE. The subject is Transform and Boundary Value Problems. So this is first video homework problem from the PDE by eliminating arbitrary constants. So the question is x minus a whole square plus y minus b whole square equal to z square cot square alpha. So first, how many arbitrary constants are there? 2, that is AB. What are the independent variables? X, Y. Dependent variable always z. So two arbitrary constants, two independent variables. So you have to follow the case one. Case one type, because arbitrary constants less than or equal to independent variables, we have to use the case one. So first we have to differentiate the equation first with respect to x and then with respect to y. So consider this equation is 1. So first partially differentiate equation 1 with respect to x. So with respect to x means the first term have x, second term does not have, then third term is z square cot square alpha. So first term differentiation x power n. So what is the differentiation x power n? N into x power n minus 1. So the same thing 2 into x minus a, then power 2 minus 1 1 into bracket differentiation into 1. Plus second term does not have any x term, so 0 equal to, so z is a function of x comma y. So z square differentiation to z, then this is partial, the dou z by dou x cot square alpha is constant. So now the cancel 2, balance you will get x minus a equal to z dou z by dou x cot square alpha. So what are the notation we are following? Dou z by dou x equal to p. So x minus a equal to z p cot square alpha. So denote this equation is 2. Next, differentiate the equation. This is your given equation. This is your given equation. Partially differentiate equation 1 with respect to y. So first term does not have any y, so 0 plus second term have y, so 2 into y minus b upon power 2 minus 1 1 into bracket differentiation 1 equal to z square differentiation 2z partially with respect to y, so dou z by dou y cot square alpha is constant. So 2 will cancel, y minus b equal to z dou z by dou y cot square alpha. So y minus b equal to z into, what is the notation we are following? Q, cot square alpha. So what is the notation? Dou z by dou y equal to q. So now consider this is third equation. So now apply 2 and 3 equation into y equation. What is the second equation? X minus a equal to zp cot square alpha. This is your second equation. Y minus b equal to zq cot square alpha. This is your third equation. Apply into equation 1. So x minus a whole square plus y minus b whole square equal to z square cot square alpha. This is equation 1. Apply 2 and 3. Put 2 and 3 in equation 1. So what you get? Zp cot square alpha whole square plus zq cot square alpha whole square equal to z square cot square alpha. So now apply square inside, z square p square cot square cot power 4 alpha plus z square q square cot power 4 alpha equal to z square cot square alpha. So see, in this equation z square is common, So cancel the z square and then cot 4, cot, cot power 4, cot power 4, cot square. So divided with cot square. So what is balance? P square, cot power 4 alpha, q square, cot power 4 alpha equal to equal to cot square alpha. So now divide with cot square alpha. So what you will get? P square cot square alpha plus q square cot square alpha equal to 1. So take it cot square alpha common equal to 1. So p square plus q square equal to 1 by cot square alpha. So 1 by cot square equal to 1 by tan square. 1 by cot square is tan square alpha. So 1 by cot is tan. So this is the required PDE. In second video homework problem, find the PDE of all planes passes of all planes uh, through the origin. Through the origin. So the solution is first you have to write the general equation of the plane. Ax plus by plus cz plus d equal to 0. So this equation denoted as 1. So this equation passes through the origin. So 0 comma 0 comma 0. Therefore, the fourth constant will become 0. Here this is represents x, y, z. So then the fourth constant will become 0. So what you will get? Ax plus by plus cz equal to 0. So the equation 1 turns to Ax plus by plus cz equal to 0. So now Ax plus by plus cz equal to 0. So how many arbitrary constants? A, B, C. What are the independent variable? X and Y. See, always we are seeing all equations are represent z equal to. So here C is z there. So multiply with C, A by C x, B by C y plus I will get the z alone in the third term. Now A, C both are whatever it is constant. That's why I make it as common constant A1. This is common constant of B1 because B also constant, C also constant. So B1y plus Z equal to 0. So now how many arbitrary constants? A1, B1. What are the independent variable? X, comma, Y. Now apply the case 1. Now apply the case 1. A1x plus B1y equal to minus z or plus z equal to 0. So partially differentiate. I monitor this equation is to partially differentiate equation 2 with respect to x. So a1 second term no x 0, third term z differentiation with respect to x 0. Next partially differentiate equation 2 with respect to y. So first term no y, second term v1 into y, so v1 into 1, third term z differentiation with respect to y, dou z by dou y equal to 0. So a1 plus What is dou z by dou x? Rotation p. So a1 equal to minus p. Here p1 equal to dou z by dou y, which means minus. So b1 equal to minus q. Now apply this 3 and 4. So apply 3 and 4 in 2. So what you will get? What is to second equation? So this is p minus p x minus q y plus z equal to 0. So finally you will get z equal to px plus qy. This is the required PDE of this given equation. So next, some small example of linear PDE and nonlinear PDE, just for revision. Linear PDE, nonlinear PDE. So this equation, dou square u by dou x square plus y dou square u by dou y square equal to 0. This is linear equation. And then one more linear equation, dou square z by dou x square plus 3 dou z by dou y equal to x plus y. This is also linear equation. And one more example for linear is dou cube z by dou x cube plus dou z by dou y equal to 0. See, this is linear equation but third order. This is linear equation but second order. This is also linear equation but the order is 2. And then for examples of nonlinear, dou z by dou x whole square plus dou z by dou y equal to 0. The square term decides the whole equation become nonlinear. Next one, dou u by dou x whole square plus u dou u by dou y equal to 1. This square term and also u dou u and multiply with its derivative. So these two terms decides this equation is a non-linear type. And also one more example problem of linear, x dou z by dou x plus y dou z by dou y equal to z. So here z there, but z is uniquely standing here. So not multiplied with its derivative. Therefore, this is linear. Next one, for non-linear, dou u by dou x whole square plus dou u by dou y whole square equal to 1. So because this is whole square representing. So this is non-linear. And dou u by, this is non-linear. Yes, many students are confusing about linear and non-linear equations. So that's why we revised like that. Can you guess what is the type? Here whole square there. Previous already seen. So you multiply with derivative. This is obviously non-linear. In case instead of for example dou square u by dou x square plus 2 into dou square u by dou x dou y equal to sin x. Sin x. This is sin x. So this equation is a linear example. This equation is a linear example. See, what is the equation? Dou square u by dou x square plus 2 into dou square u by dou x dou y equal to sin x. This is the linear equation. And also one more linear equation. Dou square u by dou t square equal to e power minus t. Dou square u by dou x square plus sin t. This is also a linear equation. A linear equation, but order 2. But order 2. Thank you.